Hello, Mr. Hausler here. This video is for Chapter 7, Math 8 class. Chapter 7 is about slope and association. The skill this is over is calculating slope in a variety of situations. So students are going to have to know how to calculate the slope as an equation, figure out the slope if I have a graph, figure out the slope if I have a table, and figure out the slope if I have a situation, or basically what's the story problem. And we're going to use those different methods of calculating slope depending on what situation we're in. For example, this one here, y equals negative 2/3 x minus 8. I should be using the fact that I know that's a linear equation, y equals mx plus b, and I know that this represents the slope, and that's the y-intercept. I'm focusing on the slope, so all I need to know is what number is sitting right there. In this case, negative 2/3. Moving to the graph. Our graph, I'm probably going to use that's bad, I want rise over run. I was thinking that's my m value, rise over run. So this guy, getting from this point to this point, it's rising down 2. So negative 2 is my rise. And it's going to the right 1. Hopefully you can see that. It's also on the Google Docs. You'll be able to view it there. So my slope in this one is negative 2 over 1. In math, we always want to simplify. If possible, simplify. So the answer is simply just negative 2. I don't need to put over 1. It's just a negative 2. When I go to the table, I'm not going to use rise over run. I don't want to have to draw the graph. That would be too much work. I want to do something more efficient. And that would be my change in y values over my change in x values. It's just a little bit more efficient that way. I'm going to pick out 2 coordinate points, figure out how the y value is changing, figure out how the x value is changing, and write a quick fraction for my slope. The beauty of this is I can pick whatever 2 points I want, so I can avoid these larger numbers. I'll stick with these numbers. And if it has a 0, that actually makes it easier too. So if I want the change in the y values, I went from a 7 to a 13, so that increased. And that makes it a positive 6, a change of positive 6. That's what that delta means, it's change. Now the change in the x values, delta x. That would be going from a 0 to a 2, so that's a positive 2. And again, if I can simplify, I need to simplify. So 6 divided by 2. Slope in that situation is a positive 3. Going to the last one, our story problem, or what we call a situation. In the morning, there was already 10 inches of snow on the ground. As the day went on, the snow continued to fall 1 inch every hour. Irrelevant information, kind of like a red herring, it's sort of throwing you off. This is the important information. 1 inch every 2 hours. So I actually kind of make that my slope. 1 inch every 2 hours. That is my rate of change, which is my slope, 1 inch every 2 hours. Sometimes they will want your unit rate, so what is it doing every 1 hour? If it's doing a full inch in 2 hours, 1 hour's time, I can just divide those two. 1 divided by 2, you get a 0.5. So if they wanted the unit rate, I would have to actually give them this answer. Tells them what happens in 1 hour, half of an inch, 0.5 of an inch in 1 hour. 0.5 of an inch of snow is coming down every 1 hour. So that's our ways of calculating slope in a variety of situations.